Good afternoon. My name is Tushar Singh, and I'm happy for you to join me for this final presentation of the day ahead of the student closing remarks on customizing corporate training through AI. As mentioned, I am Tushar. In case you've attended Enable AI in person, we've likely spoken, but if not, I'm the CEO and founder of Minute School, and I have a deep experience in AI, machine learning, as well as education. Our first EdTech product as part of our group that builds EdTech products and platforms was in 2006, where we used it for large-scale training. What I'm hoping to impart to you today is a applied and product-centric view towards using AI in corporate education. If you've joined previous talks or attended one of my previous presentations, we've spoken about firstly, AI in special needs education and how it could be utilized there. You've probably spoken to me about how AI could be used in higher education as well. We probably haven't spoken about corporate education, but that's primarily where I do quite a bit of my work and my team does quite a bit of their work. And you have to use a specific understanding and product level understanding before you utilize AI in those situations. And what I'd like to do is take you through several use cases, but an understanding of how you arrive at a implementation of AI and utilize it to customize education in education and what customization really actually means. So first off, let's start with a simple question. How is change created in a business? So this is a important question we ask in education, or educators ask at least when they're working on the design side and then also the delivery of material. But how do I create change? So regardless of the size of your organization, whether it's a business or it's a higher ed or it's a daycare or it's preschool or anywhere, or you're a senior that's working on educating yourself further after retirement, in order to create change, you must educate. And that's why education is so fundamental to every single part of society, is that education, communication is the only way to create change. You cannot change change in a person, and a person cannot create change within themselves without communicating with themselves, without some sort of analytical process to actually look at where they are, intake or learn from it, take in more learning materials, and then create a process of change. So when we actually look at creating change in a business, we're going to be needing some sort of education to do that. In order to get started on this, I also want us to look at business not as a monolith. There's different roles. So let's actually look at why we might want to create change in a business as well. That we do want to answer that question so that when we actually examine the specific use cases, we can start to dig into with a different lens. We can start to look at that from a process change mechanism, and we can start to look at breaking down and optimizing processes rather than just we're teaching courses. We have to know why we're teaching courses. And the reason for that is in a business, in life, anywhere, there's a cost to actually any sort of learning material. Usually that's measured in time, and you probably heard time is money. And that's because when we're looking at a typical sort of organizational unit in any sort of business, there is a structure that we typically have that scales. At the top of this diagram, there's the lead. The lead may have a number of managers, 4 in this case, who in turn direct 2 team members each. Now, the reason why this exists is the ratio might be necessary due to a few factors related to key metrics with regards to business goals. So when we look at business goals, we can look at both revenue and profit, and there's a direct relationship to how the team members, managers, and leads work in order to convert the revenue to a profit. So let's say there's sufficient demand in the business or for whatever the business produces. How can we generate more revenue? In our case here, we could likely do that by hiring more team members and managers. But that actually has a limit, because for every 2 team members, we must add a manager. So then we also look at how do we increase productivity or efficiency, because if we can do that with the team members and also the managers, we can then increase profitability because we can then have team members doing more with what they have, as in increasing their efficiency, or we can actually add more team members potentially if we make the managers more efficient in order to increase the productivity at that point as well. So for each and every single one of these cases I've mentioned, we need to change how the organization operates. So we may choose to do this by training managers to manage more team members and essentially increasing the ratio. And if we could increase the ratio from 1 to 3, we don't have to add managers to certainly add 4 more team members. And certainly there's a cost to the team members, adding the team members, but they should be able to produce more to offset that and increase both our revenue and profitability. We may also choose to train our team members, and that can increase their productivity and or efficiency. Hopefully both, but if we can do that, then once again, we can increase the profitability of our business. So how do we actually accomplish this? And I'm going to take you through a few different models, but increasingly the preferred mechanism is through something that we call M-learning, which is microlearning. So if you have worked at a company before, you've likely gone through sitting down for big presentations or going through some PowerPoint that takes an hour, or you might have to sit through a day-long training. And that is very much becoming a legacy sort of model in order to do training and change in an organization. More increasingly, microlearning is used, which is consuming small amounts of training material through some sort of online platform rather than going and sitting in a classroom. If the platform supports it, then this can also be consumed on a mobile device. Once again, M-learning at that particular point. And these sort of mechanisms have been around for quite some time. They are used for large-scale training because devices are essentially available everywhere right now. And especially over the last few years, there's been a large transition, a greater transition, I would say, to this sort of mechanism. And that's because work from home has required the actual workers to utilize their own devices to a great degree. And then when coming back into an environment, if training can be done without coming into a classroom, there's been a lot of benefit from a health and safety perspective. So the last 3 years have definitely created a surge towards M-learning. The other thing that happens with microlearning is that it's typically continuous, as in delivered across multiple days, and avoids large blocks of downtime. It can also support traditional forms of training, such as seminars, by improving knowledge and skill retention by following up. So you could still have a seminar, but then the follow-up can come through. Now, of course, the question is, what do you follow up on? And that's where we'll jump into it shortly. But you are looking at these mechanisms where there's a greater understanding within organizations that education isn't a one-time thing. You can't just teach one time and then walk away. It needs to be continuous in nature, especially because it will increase and give an edge when you're talking about productivity and efficiency, which in turn relate to profitability. So let's jump into the next part. All right. So how do we apply AI to education to achieve this? Well, perhaps we should be also asking, why do we create the change? And I've answered that with, revenue, profitability, and expenses. But let's talk about the AI piece. How do we actually apply this in order to achieve it? And for this, I'm going to go back to a definition. If you've gone to my previous presentations, I like to have this definition here. An AI is a machine that exhibits the ability to solve problems. And there are many definitions. For the purposes of this conversation, we are trying to solve problems. We're trying to have a software decision-making system, essentially. Because AI isn't something that you can just be like, here's my learning material, teach. Well, there's no goals, there's no outcomes. So we have to build a framework around it. And that's the product-centric view that we need to actually utilize. So sometimes I use the phrase to include expertly solved problems as well as part of what we're looking here. And that is the framework. You still need someone who understands the organization goals, the processes, what they're trying to achieve, and to work backwards to say, here's the change program that we actually need. And we'd say expertly as well, because we want that AI to work as well as an individual, if not better. Based on the cost of the AI, we will obviously look at the outcomes, and we may balance and say, yes, slightly worse AI is good enough because it is very inexpensive and it allows the expert in our organization to solve more problems. So we want to inject AI now into a decision-making process. And there's really two areas where we can utilize AI. And they're two very simple areas. I don't want to take up a lot of room on this because I want to emphasize there's two areas where we utilize AI. One is in analysis. And analysis is using AI to enhance analysis of activity. So we're using the AI as an augmentation here. You can certainly have reporting in an organization, but that tells you what has happened through data, and it simply presents it in a nice to have fashion. But you could then use your AI for a prediction. So when you look at reports, you want to see where we are going to be, not just where we are, not just the backwards looking, because the people who are looking at the reports need to have some level of expertise. And that makes it difficult to scale. It makes it difficult to train that particular group of people on how to interpret reports for their own planning. So this is where we then use that AI to say, if we can have this AI predict, and we can put it into some sort of wrapper and presentation that a manager can look at, and then they can look at that and say, in the future, in 3 months, this is where we're going to be. You can utilize their business expertise and planning expertise in order to actually implement certain tactics by that stage. The managers can have a more strategic conversation about this is when our team will be ready to execute on this area, or this is when our sales team will be trained to a point where we can start to go and insert it into our cold calling process or our sales process. And this forward-looking element is very powerful and typically lacking in many organizations in a strong methodical manner. And we're seeing now more and more AI is coming in to actually not only analyze where the other parts of a business in terms of supply chains, et cetera, but also we are in the process of a change. When will we be ready? When will this change be complete? The second area is to use AI in a directive manner. And this, once again, uses the predictive abilities and projection to determine what the learner should engage with next. In M-learning, this is especially important because you have small units of learning. You might have 100 of these. You might have 1,000 of these if you have an extensively large program. You might have 50,000 of these if you're trying to train your learners on every product in your organization. So if you can indicate specialization, you can bring the problem down in scale, but still, you can't have them sit down and read a catalog and expect them to memorize it. But having a progressive training mechanism allows you to progress the student forward. And we'll come to a particularly interesting use case of this, and I'll share with you a few anecdotes from an actual deployment or two in that area. So let's jump into why we even use an AI. And I want to look at this from a learning environment perspective. We now have the student, there's a learning environment that they can engage with. We're going to go back and say, why use an AI? Can we correlate something back to primary measurements, profitability, revenue? Can our education performance be improved through AI? It's important to understand that when you're looking at a particular individual in a workflow or on the floor or sitting in a chair, you're not really measuring them directly to profitability, revenue, where they are. They are being measured through a different sort of mechanism. They're being measured through productivity and efficiency. So you need to have some mechanism where you can connect the education back to them. So I come back to the question, can our education performance be improved through AI? The answer is yes, but it has to be used within certain product context. Straight consumption of non-interactive material does not lend itself to AI usage. However, if a product has a decision-making path, then AI is a good fit. So when I mean non-interactive material would be read this PDF. If you're not going to have any interaction in them and you have no measurement mechanism, there's nowhere an AI can really act in that PDF or that straight text mechanism with some images interspersed. If, however, you have a measurement mechanism contained within, such as some questions. You can then use those to determine what do they need to look at next. You can also use those questions to determine, did they even understand and comprehend sufficiently what they went through? So the use cases I'm going to go through now are things that we have currently used in AI, and the processes and where the AI actually injects itself. So I'm going to have a particular use case now of quiz questions. So quiz questions are very important because within a particular quiz, you want to get really anyone through that quiz as quickly as possible. If they're spending time in learning material in a quiz and they've already reached a sufficient point of measurement where you know they know it or they don't know it, you're just wasting time spinning through additional questions. So we don't necessarily like to say you're only going to get 10 questions and that's it. We really want to ask you the best set of questions for you. So with a very lightweight version here, when we go through and say with quiz questions, we want to say, what questions should we ask a student? And the reason why we need to select these questions is that we could have 100 questions in a question bank, where we have some easy questions, some medium difficulty, and some very hard questions. And the hard questions could involve correlating multiple pieces of a process together. It could involve solving a problem on how much a mortgage should be given for and what should be weighed by the lender in those sort of situations. And that sort of training requires a lot of knowledge and then the skill to put it together. So those harder questions might not be something that's useful when you're training someone who's a new trainee, but they could be very useful once they've received some training as a measurement of, are they ready to put in front of a customer, and are we confident that they're going to be making good decisions that will be good decisions both for the customer as well as for the company. And we don't want to ask them 100 questions straight because we don't really learn much from that, especially if we get through the easy questions and they're not doing well and we have to deliver training to them. So what questions do we ask them? Well, as I've mentioned, there's already a number of factors to take into account. But with an AI, what you can do is that you can actually build a system where you ask it, what questions should I actually ask right now? And it can weigh a number of factors. It can weigh how many things a student has already gone through. Have they answered previous questions? What training has it gone through? And based on the model that it creates on the students who've gone through previously and how it's also being trained on that, it can very effectively say, this is the set of questions we need to ask the student right now. And that set of questions is a place where the product designer comes in. Because what we do is we get a prediction on every question in the question bank as to how confident we are that the student will answer it correctly. And that's where we then start to say, let's give them 3 questions that they will answer correctly. We believe they will answer correctly. Let's give them 5 questions where there's going to be a 50% chance. And let's give them 2 questions where they're highly unlikely to actually answer it. And there's got to be a method behind that selection. We can't simply say, AI, pick whatever you want, because there's no structure given to the AI as to what goal we're trying to achieve. But as a product designer, if we say, here's 3 easy, we're asking them these to build confidence. Then we're going to ask them 5 to test them. And this is where they should be developing. We're going to ask them 2 hard ones. So now they have something to think forward to, because once we've completed training them on these 5, we're going to build into that next 2. And that's part of the design from a product perspective that we go through, and that when you're utilizing AI that you need to go through. There has to be a mechanism for what are we trying to achieve and how do we use AI for that decision-making component. We also look at assessments within what we do, and increasingly, this is the case for many HR departments as well that we work with, is that assessments aren't only for summative examination. This is quite often the case that happens in higher education. You get very large exams at the end of a course or at the midterm. But in a corporate education case, you want to use these as learning moments, because if you can have the student learn at that time, you have delivered the education where then they can complete what they're doing, and continue with their day, rather than saying, we now need to have you sit down and look at this 10 minutes again. An example of this is, of not a great experience of this, is if you've ever taken any sort of licensing course, where if at the end, you go through 2 hours of training, and at the end of it, if you don't pass the exam, you have to go through all the training again. For some of you that are looking forward to boating this summer or working on your boating license, that's how the test, or at least last one I did it, works in Ontario, is that if you don't complete your education or the exam, you have to go through all the training again. A quiz that can teach you along the way will significantly improve outcomes for that summative, because you are now providing an immediate response. And the AI also knows this, that it's provided you with a response. It can treat each question as learning material rather than only as a summative and a data collection point for, did you get this right or wrong? I'm going to move on to another use case here. And that's actually when we spoke about direction, is how can we possibly make adaptive courses? This is also a big thing that we do in Minute School. This is what other learning platforms also claim to do. But this is how the process works. And what we do is that we really like to use pre-assessment in corporate training. And these pre-assessments essentially allow you to shrink the content that will follow in the course to only the pieces that a student needs to learn. And once again, if we're saving time and we're confident in our ability to save time, then the outcomes for the business are much greater, because the business can now engage in teaching, or sorry, not teaching, but utilizing their actual, their workers to actually be producing, and their managers to actually be producing, rather than going through a very lengthy training process. And we'll look at a few more use cases of inline shortly, but these pieces that we're setting up here are fundamental to more complex use cases. So in a pre-assessment, as you can imagine, there's a set of questions that you go through. That is then fed into a model which looks at previous workers going through in a similar manner, and then determining what the course should actually look like. This has the ability to massively shrink down the time that is spent in learning material. It's especially useful when you're going through annual licensing or annual training requirements or quarterly training requirements. If you can do an assessment that is similar to the final assessment and demonstrate that there is an understanding, then you can vastly shrink down training annually that might be an hour or 2 or 3 down to 15 minutes or less. And the key in this model is that your pre-assessment is very similar to your final assessment. So if you're looking down the right here where we've got content A, B, C, D, E, after that, there would actually be a final assessment. And what you're doing is your input data is now also correlated to your output data, which is that final assessment. So initially, when the AI doesn't know that much, can't really produce a great model, what it will do is that it will still produce a longer course. But then by correlating those initial questions to those final questions, then it'll be able to say, okay, I have an understanding now of the confidence that I can put into a prediction. And you can create a really good model for pre-assessment that allows everyone to be much happier because they're moving through training fairly quickly. It's important to recognize, though, that no single AI prediction can be used in every use case. So we've looked at the quiz system. We're now looking at the pre-assessment system in terms of predicting what they know and don't know. You have to find a way to create a correlation between the questions and the topic areas. So as we mentioned, these questions here on the left to the topic areas on the right. And you can then attempt to ask questions in those areas. But that AI model that you use may not be the same as what we used previously for determining quiz questions and predictions with quiz questions. Depends on how you're going to correlate those topic areas to those questions. So this goes into some of the product design as well. The actual AI model that we write in Python, Go, C, or C++ is really just data crunching. It's part of a pipeline. We then have to put it into the product pipeline and give it parameters and definitions And so it exists as a much larger framework, but a fundamentally important part. So the data we produce in different areas, we want to pipe that into the AI system. And when we're looking at the broader platform as AI developers and AI product managers, we're really platform product managers, because what we're going to do is not going to work well if we're not producing the information, the data that we need from each of the other areas of the actual platform. So it's important to widen your scope and think and look at the entire problem as you grow confident in your abilities to actually work on that technical piece that's in the middle. And that's something that we do fairly well. So we're going to jump into a next use case. And this is an important one because this is a use case we call once a day. About that, we look to have some technical difficulties, but we'll just roll with it. So I didn't skip ahead. I've gone to this slide here called once a day. And we're going to talk about some privacy concerns as well. We utilize this model not only in corporate, but also in our education products, so K through 12, sometimes even younger. And we also utilize it in our higher education products, this model. So we're very familiar with this. And a once a day model is very powerful from a learning perspective because it drives a student learner. And one of the first implementations of AI that we built as a team, this was prior to Minute School, was for an organization with 20,000 or close to 20,000 team members. We were given some very strict requirements for this. The program needed to save time and take no more than 1 minute each day for each of the team members. So that was great. We got close to 20,000 training minutes, but only 1 minute per team member. And it's very difficult to imagine making an impact over that time. So we conceived of this: how can we teach the student learner the most important thing they need to know right now? And how can we make this material as concise as possible to get across to them what we want to get across to them? So what we did is we conceived of a model where you get a daily question. And that daily question was actually determined by an AI, because the AI, with the student coming back every single day and 20,000 students coming back every single day, could develop a pretty good model very quickly of where all the learners were and what they could understand versus not, and where they could get something correct versus not. And so this is where we started doing meta tagging and essentially associating competencies at the same time. And we conceived of this daily question where the AI would determine and then give them a quick bit of learning following that. And that learning was connected to that question. So right or wrong, the student would receive a piece of learning at the same time. That also had the benefit of, when we actually added NLP, is that we could analyze the content of the questions as well as the content of the content that followed the learning material to create a strong relationship and model for a relationship between the two, which then would allow us to extend that learning and perform a higher level analysis with another AI system to actually analyze our questions. Were they good questions? What material was related? But I'm getting a little bit ahead of myself. This methodology that we're looking at utilizes both of the previous methodologies we looked at. Is we have an AI that is being used to determine what question, and this is almost acting as a pre-assessment. Rather than asking a series of questions all at once, we're asking them across a longer period of time. And the reason why this is important is our program eventually expanded into asking several questions and assessing what the student needed to know and providing them with that rather than the content directly related to the question. So we were actually able to say, we're going to ask the student some set of questions, and we could then present them with material that was not related to those questions directly, but rather have the model that they didn't get these questions right somewhere. We need to actually jump back and show them learning material that they should have learned previously, or that they had forgotten. And this sort of learning and reinforcement learning is very important. And in order to have long-term retention of knowledge and skills, and also adjustments in attitude. And by using the AI there, we were not bound tightly to this question, this content. Instead, we were saying, hey, this question they got it wrong. We're not so confident that they actually know the underlying material that was taught to them 2-3 weeks earlier. So let's go and do that. And the outcomes on this were massive. It was actually an insurance and saving program for loss prevention for an organization in the US. And we resulted in tens of millions of dollars of savings through this process and this program. There were incentives given out in order to get the learners there, but the actual program from an education perspective also gave the organization a proof point that we taught the student this. And then it also allowed the students to be confident that corporate was looking out for them. Now, we use the same model in higher education. We call it it is utilized quite often for exams in the 48 hours preceding an exam, where a student says, here's what I have on my exam, and here's what I need to do. And it does help them prepare for those exams. It works much better if you start earlier in the term, but it is used for those sort of elements. The other area where we use this is in math education for K through 9. And it has, we started at grade 9, then grade 8, and worked our way down because there was a concern about privacy with the students. And what we find with the data for students is you can pretty much be on side as long as you examine the cloud solution you're using, in which case, this case, we had developed it, but also deploy it into the correct jurisdiction. Because the AI, while it works in a pipeline and takes in quite a bit of data, we want to ensure that it's only receiving the data that is necessary for it. And while it might have some private information associated with it, we want to try and scrub that and have it not really looking at those fields. So there are certainly a lot of concern on the AI privacy side, and rightfully so. If I can switch gears just a little bit to tools that are utilized in software development, there are AI coding tools that are available from a variety of providers, including Microsoft through GitHub and the analysis there, as well as other platforms that do large analysis of code bases. And one of the big problems that we see there is sometimes information that you think is only visible to yourself starts to become apparent in other people's codes. A fairly modern example, or recent example, is an AI tool was used to develop smart contracts, and along the way, a private key was automatically inserted. This happens as well, not even in smart contract development, but any sort of development, is when you have a configuration file and your AI tool decides to autocomplete that information. And it could autocomplete it on a real private key from someone else, or a password, or some other mechanism, or a secret key from someone else, because that's what it's trained on. It thinks that's what you want to actually insert now. And the more developers insert that using the tool, the more it reinforces the tool, the AI system, that, oh, this was the correct decision I made. So it's very important to try and scrub personally identifiable information from what's being fed into the AI system. And we do that. We do that by essentially creating a meta layer where the student's private information, PII, is essentially just assigned a random identifier. And then within the platform and the AI systems, there's only the random identifier, if that. That's the only correlation to the data. That way, because students and learners in a public platform who are directly engaged with us have the right to forget, it can be scrubbed. Now, that might not be the same. You'd have to look at from a legal perspective of what a worker's right is in an organization, because there is a contractual relationship there. But for younger learners, it's very important. It's also important for when younger learners come into corporate, for corporations to recognize what sort of protections do we need to have for these learners. If they're under 18 years of age, while they might be able to sign a contract, they're still a minor, and based on the jurisdiction, they might not be able to engage and provide their information to go to certain cloud platforms, because those platforms might be in jurisdictions that are not as friendly from a privacy perspective. So those are also things that should be considered. For us, we work with our clients very closely to say, where should your information reside? Should it be in Canada, the United States, the EU, in Singapore, and even in China behind the firewall? So you have to have these sort of conversations when you're going through the product design perspective, and you have to bring privacy to the forefront of understanding your data. I'm sure all of us can build models, or most of us can build the models fairly quickly and crunch some data, but you have to take that wide organizational product lens in what we're trying to actually achieve. So the other question that has happened is that, say that we're pushing these recommendations, do we gather feedback on these sort of elements? And the answer is yes. In some cases, we do actually ask, is this relevant? Did you find this relevant? But in many cases, we don't actually need to. What we do is we look at the outcomes and we look at, are we achieving a high level of success? And sometimes it's useful to manually insert a piece of assessment that is broad in scale to actually understand, did you achieve success? Are the students actually achieving that readiness across all of the subject matter areas that your system is predicting? It's always important to test, and you don't need to do it with everyone. A small group is fine, but that also needs to be thought of from a product perspective. I'm now going to go into the most complex scenario we've encountered so far where we utilize AI in an educational environment. And this use case is just-in-time learning. And what this isn't someone who's working sitting down and expecting to go through learning. Rather, they are working. And the learning is interjected, it's inserted into the work process that they're doing. This is especially important in places where you want to hire someone and get them productive as soon as possible, and you can progressively educate them. So this can be used in a variety of different environments, including e-commerce fulfillment centers. So you can imagine there's a lot of e-commerce fulfillment centers, and from many different companies. And this is a methodology that can be utilized in those environments. They can also be used ahead of client meetings for sales teams. So when in a sales team, you might not have everyone on the same page. You might also have, if you're having a sales team meeting or a client meeting, you might have product engineers there. You might actually have the manager, who the client relationship or a customer relationship manager, who's an engineer or a product specialist there at the same time. And you can have training that actually says, here's who you can expect in the meeting. Here are their roles. These might not be important things ahead of time, but they can be important just in time. Or they can have been a change between the previous meeting and a new one in some changes of relationships, and someone who has identified that change can create some training, which then goes into a quick pre-assessment. It's also utilized heavily in call centers and factories, really anywhere where you need to do on-the-fly insertion of some quick training or any sort of materials. Because of this injection mechanism, it is the most complicated to build and apply an AI into. The general process requires constant evaluation of our learners' tasks. So not just what have they learned, what are the questions? There's an analysis of what are they working on? Have they done this before? How confident are they're going to actually perform this task correctly? And based on that, a determination of whether to inject learning material or an assessment or both, dynamic content as well, and then returning them to the workflow. And then evaluating whether they did that correctly. And an evaluation isn't necessarily immediate. It could happen weeks later. For example, there was some sort of ordering process. There was some sort of invoice generation process. They were educated on it. But when did that come back into the flow? That becomes complex because the event that happens later on and far into the future should actually be considered and inserted at a specific point in this time frame, depending on what they've learned as well since then. So there's a complexity on how you have to train the AI and continually train the AI systems as well at the same time, because you need data streams from both the platform, the education platform interactions, as well as the external systems. And events can flow in from calendar sources, HR management systems, equipment that they're operating, from financial systems as well, from auditing systems, and a whole bunch of other event streams. And the key is this information is streamed and contains timestamps to form a history of what the learner is going through. Training for such a system is can seem really complex, but due to the generalized event-based nature, it's fairly straightforward to generate the requisite training data sets. And then there's a continual feedback loop as well that over time reduces the error rate. This tends to have the most generalized AI systems as well, because you're dealing with large volumes of data from different places. Your AI model and system that takes data in tends to be simpler, even though the actual implementation and the number of nodes or neurons internally might be fairly great. So this, though, requires the most broad product understanding possible. It also has some of the best returns because it can get someone who is hired onto and into a chair or on the floor for working as quickly as possible, and has some immense returns. It's the same sort of thing that I do with a developer. Is I try and get my developers writing some sort of code that ships in the first week because it gives them ownership. But that's really difficult to do. It requires time and attention and care from the manager who's actually working with them. But it's a great achievement because that means that we now have taught them sufficient amounts to get them productive and in order to produce and give them bigger projects. That is a goal for many businesses now in the modern days, where we're trying to adapt and move as quickly as possible. The last use case I'm going to come to is reporting. I have touched on it before, but not just showing where we predict where learners are going to be, but also projecting where they're going to be in an arbitrary amount of time into the future. This forecasting I come back to is extremely important. Strategically, it allows you to build strategies and then align the timing of your tactics and be confident as well that you'll be able to deliver at that time. We can make predictions on the competencies of topics also without the learners even having engaged with them. So this is an important piece of, we've only gone 10, 25% through a course and the basic evaluation we need to do, but we can predict on the remaining 80%. And while it might seem that this is relatively inefficient or uncertain, because of the vast amount of material we've had go through previously, and that employees being hired by an organization have come in with some level of standard, it's not random input. It's not like what we would see in education and higher education, K through 12, where you have students at all different levels and capabilities coming in. In our case, we're looking at bringing in a fairly homogeneous group of individuals that we can then predict where they will be. And so it has far less variability and susceptibility to chaos in this system as compared to, I would say, weather prediction, weather forecasting. Finally, I want to talk about how you may not want to deploy AI immediately. We call this an eventual AI model. It should bear out that AI need not and should not be deployed without structure, that training is needed, and even then confidence in the output it's giving is needed. If the AI is not ready or doesn't provide a value that we can be confident with, we should switch over to a more static set of rules. And you have to build some sort of static set of rules because you have to understand this is not just we put things in and it's magic and figures it out. No, we have to think about what are the outcomes, what are some of the rule sets we want to try and have it essentially closely match but improve. When the AI is providing values, whether it's a prediction value or competency score, confidence, then we can move towards it. This is a big part of product design and the application of AI. It's not blind application and trust. It's also important to consider mixing multiple AI models together, where a simple model provides predictions early on, and then as more data is collected and the accuracy of a more sophisticated model improves, you can then switch to it. This requires product metric analysis as well as cost analysis to determine the improvement in predictions. I'm going to come back to the thing that I said at the beginning, the environment that you deploy into. There's no such thing as a self-deploying AI. A product environment must exist for the AI to deploy into, where it will be used to either output predictive information for display, or the prediction will be used in a programmatic decision-making process. So You cannot just blindly think AI is going to solve our problems. It has to fit into a framework that you already have. And then just wrapping it up, you must have some goals that you measure against. If you're in corporate education, you're deploying into corporate education, there have to be goals that you're meeting. You have to be able to measure those as well, because you have to be able to measure the change you're trying to achieve. That metric can feed back into the system as well. Education is the only way to create change. Communication is a big part of that, and you cannot create change without influence. And you can also create change by pushing outwards. And you have to measure those primary factors. And those primary factors could be how many units are they producing per hour? How quick are they? Those relate back to revenue and profitability, but they're not necessarily apparent where you're actually working. And the platform that actually gives you sufficient data and your ability to capture from that platform is also immensely important. What I hope that you've taken from this presentation is that you have to be looking at a wide lens when you're implementing AI. If you are only operating in a technical capability here, you still need to be looking wider, because you need to be understanding what product impact you're trying to make, and that will help you have greater impact in the change that you're trying to create. Thank you very much. My name once again is Tushar Singh. You can email me and connect with me at tushar@minuteschool.com. If you'd like a copy of the slides as well, please let me know. Happy to share. And thank you again to DC and the AI Hub for having me here today. And it's been a fantastic journey with you. I look forward to many more of these.